Okay, so this week we are discussing about node voltage method. Again, another method that we can use to analyze a circuit. So analyzing a circuit means we just started, Lachlan. You didn't miss anything, okay? We just started. So analyzing a circuit means finding unknown resistors, unknown currents, voltages. That's what we call the analyzing or finding unknown things. So to find unknown things, we discussed few methods last week. We discussed how to simplify a circuit by combining resistors together. When resistors are in parallel, we know how to make it to a single resistor. We know when the resistors are in series, what we need to do. And also we discuss about Kirchhoff voltage law and Kirchhoff current law. So those ones are basic concepts which we can use to analyze a circuit. And today, first 5 weeks, as I have told you last week, we are discussing about different methods to analyze a circuit, and we will be using them later to do other complex questions. I am recording this.
Sorry, Yubika, I thought you weren't recording.
Oh, no, I am, yes. So not voltage method. Let's see what we have to do in this one. So again, we are using here using basic theories. As I have mentioned, we can analyze a circuit, and node voltage method is the method that we are going to learn today, and also mesh current method, another method which is we are going to learn it next week. Superposition method, another method in the coming weeks. Source transformation is another method. So we are going to learn all these methods throughout the first 5 weeks to get familiarized with this different methods to analyze a circuit. So Brina, we just started, okay? So I was just telling that we are going to learn this one today. Now let's see what we have to do here. So node voltage method is a method where we are using KCL. I hope you know KCL. What the KCL says, when you consider a node, whatever the current coming into the node is equals to the sum of the currents going out. So current in is equals to the sum of the currents out. So this is the basic or the principle that we are going to use to solve circuits using the node voltage method. And the aim is to define simultaneous equations and then find the currents. So we will get some equations and we find the unknown currents and we use the unknown currents. And so unknown currents will be the number of unknown currents in the circuit is equal to the number of branches. I will explain this with an example. So let's see the method steps. First, we need to identify nodes. So when we consider a node, last week we discussed node is a place where you have a connection. So here we need to consider nodes only with 3 or more branches connected. So if you have 2 elements connected like this, 2 resistors, this is a node because when the elements are connected, this will be a node. But for the node voltage method, you don't consider this as a node. You consider only where you have 3 or more branches. So this is a node because you can see 3 branches connected. When only 2 branches connected, those are, we don't consider them as nodes. So first thing is identify the nodes. Second is select reference node. So we consider one node as the reference point and we consider that as our earth or zero voltage. Then assign current to all the branches, apply KCL to the non-reference nodes, apply Ohm's law, then substitute currents with KCL. I'm going to show these 7 steps, so don't worry. So these 7 steps we are using to find the unknown currents. Let's take an example and see how we can use the node voltage method. Okay, can you tell me how many nodes are here? Node is a place where you have 2 elements connected. when you consider the theory, this is a node, this is a node, this is a node, and this is a node. But where do you have nodes with three or more branches? We don't consider two branches connected to a node. So this one is, we don't consider for the node method, and this is also not considered because there are only two branches connected. Do you agree with me?
Yep.
Okay, so we have only two nodes. So this is 1 and this is 2. Then the second step. So first is identifying nodes. So we have 3 nodes. Sorry, 2 nodes. And then the second step is give 0 volt to one node. We make it to the earth. So I'm going to consider this one as my earth. So voltage here is 0. And I assign a V1 voltage or a V voltage to the other node. So we assign voltages. When we are assigning voltages, we need to give 0 volt to one node, and you can give V1, V2, V3 like that for the other nodes. Third one is you assign currents. So when you are assigning currents, current is assigned with a direction. So I can say this branch has a current of I1 because that whole branch is the same current. That whole path, left-hand side, is getting the same current. And I can say this one is giving a current of I2. I'm showing the direction as well. Very important. You need to assign. If you are wrong, that's okay. You assume a direction and you put the arrow. Otherwise, we won't be able to apply the KCL. So if we are wrong, if our assumptions are wrong, we get a negative current. That's all right. So we assign I1 and I2. This is I1, this is I2. So this current going down from the middle path, I call it as I3. So the third step is assigning currents. Now the fourth step is applying KCL to all the nodes except the reference node. So we only have one node except the reference node. So I'm applying KCL to node 1. So this is my node 1. So KCL says whatever the current coming in is equal to the current going out. So current coming in is I1 plus I2, and the current going out is I3. Agree? Any questions so far?
No, that's all good, Yupika.
Fifth step is you apply V is equals to IR. Ohm's law. So if you rearrange this, I is equals to V over R. So we are going to write these currents, I1, I2, I3, in terms of voltages and the resistor. So I'm going to do one, and I will let you to do the other ones. So I1, we can write as the voltage divided by a current. So I1 is starting from this node here, and it is going all the way to the node 1. So we're starting with 0 voltage, and you minus all the voltages on the way. So what are the voltages on the way? We have 60 volts. Am I right? Is that right? So I'm minusing a minus 60. Why I am minusing a minus 60? Do you remember from last week? I told you whenever the current is going into the negative side, it is a negative voltage. So we start with the start point of the current, which is 0, and we minusing all the voltages on the way. So we are minusing a minus 60. Then we are stopping at this point. So that point's voltage is V1. So we are minusing a V1. Then we divide by the resistor along that path. If you have many resistors in series, you can add them together. But here we only have 12 ohms. So that is 12. So if you simplify this, you can say 60 minus V1 over 12 is our I1. Do you guys agree with me? Does that make sense?
Yep.
Will you be able to, can you please do I2 for me? I2.
Yeah, it's just minus 24.
Yes, 0 minus 24. Am I right?
Yep. Start from the voltage or from the earth.
Yes.
And then go minus 24.
Minus 24, yes.
And then across to V1.
Minus V1.
And that's over 6.
Okay. So minus will become plus. So this will be 24 minus V1 over 6. Do you all get the same? Is there anyone who don't understand this? We can discuss if you have any issues, because if you understood this, that's all for the all the questions. So if you can write this properly, that's the most important thing. Anyone have any question?
And so you just always start from the earth.
No,
right?
no. Starting point of your current. So I1 and I2 both starting from the earth. But if you look at I3, where it is starting from?
Yeah, that's what I was wondering. Yeah.
Yes, so it is starting from V1. So you're starting from V1 and minusing all the voltages. You don't have any voltage source. So V1 minus zeros, finishing at 0, divided by 12. Makes sense?
Mm-hmm.
So
Okay.
I3 is V1 over 12. Are we good? Any question? Now you have all three currents in terms of voltage, V1. So you now substitute. I1 is what? I1 is 60 minus V1 over 12. And I2 is what? 24 minus V1 over 6. I3 is what? V1 over 12. So you have an equation, just one unknown. So it's your max now. So you solve this and find the V1. How do we find V1? We have to have the common denominator. Am I right? So 12, we can keep 12. So to make this to 12, I have to times by 2 both the numerator and the denominator. So I can say 60 minus V1 over 12 plus 48 minus 2V1 over 12 is equals to V1 over 12. So we can get rid of 12 because 12 is common to all the terms. Now you can solve this. 60 plus 48 minus 3V1 is equals to V1. So you can say 108 is equals to 4V1. So V1 is equals to 108 over 4 volts. Is that make sense? We need the calculator.
27.
How much you got?
27.
27. Do we all get 27 volts? Now you can substitute this voltage V1 into the three currents and you can find I1, I2, I3. Can you find me I1, I2, I3, please? So I1 is 60 minus 27 over 12. So that will be 60 minus 27 over 12. 2.75. I2 is 24 minus 27 over 6. It is a negative value. That's fine. 0.5 amps negative. And I3 is equals to 27 over 12, which is 2.25. Do you get the same?
Yeah, looks good.
Okay, that's good. So now you look at this one now. I1 is a positive value. So I1 is going this way. So it is 2.75. I2 is negative. That means our assumed direction is wrong. So this should be this way, which is 0.5. And the I3 is 2.5. So you can see 2.75 amps is coming to towards this node. 0.5 is going towards the right and 2.25 is going down. So that's how we have done it right. That's why when you add them together algebraically, it proves the KCL, Kirchhoff law. Okay, so any question? I will give you a question for you to try, because this one we went bit fast, but just to understand the concept, then I will give you a question for you to try by yourself. Any question? So what were the steps? Do you understand these steps? First, you need to identify nodes with 3 or more branches connected. You select the reference node, give 0 voltage to the reference node, and assign voltages to other nodes. You can assign V1, V2, V3, depending on how many number of nodes you have. Then assign currents to all the branches. It's up to you, the direction. Then you apply KCL to non-reference nodes. Then you use this equation, I is equals to V over R. You start with the start point of the current and you are minusing all the voltages on the way and you divide by the resistance in that path. Then you substitute the current in the equation with this one and then you solve it and then you can find the currents using the voltage. Are we good? Okay, your question now. We did this. I will put this PowerPoint in views. Last week also I put the PowerPoint in the views if you want to find it. Okay, so this is all we done. Okay. Okay, can you do this one, please? Only thing is you have 2 nodes. Nothing, no other differences. So I will give you a few minutes and let me know if you get stuck somewhere. So you can say V1 to this and V2 to this. Let's assign currents together so we all have the same names to the current now. So let's assign currents together. So this branch, let's take this as I1, okay? So we all have the same currents. And I assume this current is going down, I2. And from here to here, we may have a current of I3. This one may be a current of I4. This is already known 2 amps, so we don't need to put an I value. We can say 2 amps to this. So are you okay with assigning currents? Anyone have any issues with assigning currents? So we just assigned currents. And how do we know 2 nodes? Because these are the 2 non-reference nodes and this is our 0 voltage. Node is where you have 3 or more branches connected. So there are only 3 nodes in this. One is the reference node, other 2 we assign a voltage of V1 and V2. Then we assign currents. That's all I'm going to do. And I will let the rest of the things for you guys. If you have any question, you can ask, okay? Vivian, are you okay? I think you joined a bit late. Did you understand?
Yep, I'm following okay, thank you.
I hope you have written I1. Can I know what you have written as I1, please? Okay, so you have to apply KCL to node. So you need to apply KCL to node 1. And also you need to apply KCL to node 2. Did you do that? Did you do that? Because you don't apply the KCL to the reference node, but you need to apply KCL to any other node. So we have node 1 where you have I1 coming in and I2 plus I3 going out. Is that right?
Yep.
And if you look at the node 2, I3 is coming in and 2 is coming in as well, and I4 is going out. So any of you, do you have any question regarding writing this KCL which we discussed last week? Current coming in is equals to current going out. How do we write I1 now? Where I1 is starting from where? These all are zero. This whole thing is zero. That's they are wires. So they are like, you don't see this like a straight line. They are wires. So they are flexible. So that whole part is connected at one point. So it is starting at 0 volt and minusing a minus 10. Why? You are going into the negative side of 10. So you're minusing all the voltages on your way. So then you are minusing a V1 divided by 1. 1 is the resistance here. So that will be 10 minus V1. Do you all get this? 10 minus V1 is your I1.
Yep.
How about I2? What do you get for I2? Where it is? Starting from where?
Start at V1.
V1 minusing
And then it goes to 0.
0.
And there's a 5 ohm
Yes.
resistance.
So this will be V1 over 5. How about I3?
It was V1 minus V2.
Yes.
And then it's over the ohm of was 2 amp. 2
2
ohms.
2 ohms. Yes, that's right. How about I4?
Well, it's coming from 0.
Coming from where?
Oh, sorry. I was going for I4. Oh, you're doing the first like I3 to I4. Is that what you're doing?
I4 is this, see?
Yeah, V2 to 0.
V2 minus 0, right?
Yeah.
Divided by 10. Okay, so you have all the currents in terms of V1 and V2. Now you are substituting them. So if you substitute the current, anyone have any question regarding the writing current using Ohm's law?
Don't you also have I5?
No, we don't have, because we can put it as I5, but it is straightforward. It is given as 2 amps. So we already know that the current in that branch. It's a known value.
Yep.
Okay. So now we substitute it. I1 is 10 minus V1 is equals to I2 is V1 over 5. I3 is V1 minus V2 over 2. So this is your equation when you substitute currents with the voltages. And the next one, KCL to node 2, I3 is V1 minus V2 over 2 plus 2 is equals to V2 divided by 10. Okay, so you have two equations, two unknowns. So you have two simultaneous equations and you have two unknowns. From your maths, you know how to solve two simultaneous equations and find V1 and V2. Does that make sense?
Yep.
Okay, So most importantly, in any paper you have with the node and also mesh that we are going to do next week, you have scored, if you have done all up to here, you have scored the most of the marks because the rest is your maths. So here, up to here, you are applying your electrical knowledge. So if you know how to identify nodes, if you know how to apply the KCL to all the non-reference nodes, and if you can substitute current with the voltages in the right way, then you will already scored the most of the marks allocated for that question. Then the next part is your maths part. You have two equations, two unknowns. So what you can do is you have two methods. You can use the elimination method or you can use the substitution method from your maths, and you can solve this and you can find V1 and V2. We are going to do that, but in most of the papers, we are asking you to obtain this equation. So if you can do that, it will be your question. Up to here, do you guys have any question? No questions? I'm going to solve this if you don't have any questions. We are going to solve this together so that you will refresh your maths knowledge. So let's take the equation 1 and we are going to simplify. We need to get rid of the denominator. So 5 and 2. So if you times by 10, oh, sorry. If you times by 10, all these terms, if you times by 10, so I'm going to write the equation 10 minus V1 is equals to V1 over 5 plus V1 minus V2 over 2. So I'm going to times by 10. So I'm multiplying all the terms by 10. When you multiply all the terms by 10, we have 10. 10 minus V1 is equals to 10 times V1 over 5 plus 10 times V1 minus V2 over 2. So this is what I have. I don't know whether it is clear for you. Okay, so we'll go to this is the same thing. Okay, let's I don't have enough space in this one to write. However, I think you can read, right? Can you read my writing?
Yep, sure can.
Okay. So we have 2 here. 10 divided by 5 is 2. 10 divided by 2 is 5. So we can say 10 times 10 minus V1 is equals to 2V1 plus 5 times V1 minus V2. So we have simplified that equation. So you can further simplify this one. 100 minus 10V1 is equals to 2V1 plus 5V1 minus 5V2. And let's make the V2 the subject, and we are going to substitute V2 in the second equation. So if you make the V2 the subject, we can take we can take V5 to the other side. Sorry, V2 to the other side. So 5V2 is equals to this one, and this one to the other side. So we can say 10, 5, 6, 17. 17 V1 minus 100 divided by 5 is your V2. Is that clear? This is just your maths. Is it clear or do you want me to do again? Are you guys okay with how I found this V2? As I have told you in your questions, we are only asking you to get the equations. You don't have to solve it, but I want to show you how to solve this because in the tutorial questions, you have to solve them. It's good to do that because it will refresh your maths knowledge. However, if you have understood how the steps to get the equations, that should be more than enough for you. But do you understand how I'm solving this?
Yep, you're bringing back bad memories.
Yeah, okay. So now you are substituting this V2 in your equation 2, and then you can get rid of the V2 and you will be able to find the V1. So we are finding V1 by substituting the V2 in the equation 2. So that's how we solve it. And as I mentioned, we are not going to solve all the questions. We are just obtaining the equation, which is the electrical part. Any questions so far? It's only few of you talking, so I assume all of you are okay, all right? So in case if you have any issues, let me know. Okay, so, okay. Now let's see when we have a dependent source, how to solve this. So you have a dependent source here, which is this one. This diamond shape is a dependent source. I told you last time as well. Dependent sources look like that. So so let's do this. I will give you time for you to solve this, and then I will do it. Just try. It's okay if you go wrong because this is, we all are here to learn. So can you please try this? You have two nodes here, node 1 and node 2. And this will be your reference node where you have voltage 0. And this one is V1 voltage. This one is V2 no voltage. And they have already given us the current directions. And we are going to write some I1, I2, I3, I4, and I5 like that. So, sorry, this is given to you as simple I. This is simple I and simple IC, and this is simple IC as well. Okay. So we have nodes, we have assigned currents. Next step is writing the KCLs. So tell me, KCL to node 1. What are the currents coming into node 1?
It's just I1.
Yes. What are the currents going out from the node 1?
I2 and is it C or whatever?
Yes, capital C, capital IC. Okay. How about the KCL to node 2?
You've got two inputs, so you've got IC and I3.
This one is I1, 2, 3. This is I5, okay?
5, sorry.
We don't have a I3, so we can put it as I3. Let's put it as I3. Okay, so this is I3. So I3 is coming in, and what else?
IC.
IC and going out I4.
Yeah.
So we have applied the KCL to node 1 and 2. Next step is writing the voltages. So how can I write I1? Where it is starting from?
Coming from the 0. Yes.
0. Minus?
The 20, minus 20.
Minus 20. Minus 20. Okay, so 2 minuses. Then minus V1 divided by 2. So this is 20 minus V1 over 2. I1. How about I2? Starting from?
You have V1 minus V2.
Finishing at where? I2?
V1 minus V2. Is that right?
It is this one, right? I2 is this.
Oh, sorry. Sorry, yeah. I was looking at the wrong.
I2 is finishing at 0 and divided by 20. I3 starting from where?
0.
0. And then you need to minus. What do you minus here? What are you going to minus?
It's minus the charge 8 times the IC.
Yes. So here the voltage is depending on the current IC. So that is a dependent source. So you have to write it as IC and minus V2 divided by 2. So you can write this as 8 IC minus V2 over 2 is your I3. So there is nothing, no big deal. Only thing is whenever you have a dependent source, you need to write whatever the thing that they have given you, the dependency. You will just write it. That one also an unknown. We will solve it. That's okay. How we write IC now? IC starting from where?
V1.
V1 and finishing at
V2.
V2 and we divided by 5. One more, I4. I4 is starting at
Yeah, it's V2
V2
over 10.
minus 0 over 10. Okay, now you have all the currents. I hope you understand how to get the current. Now just substitute the current. I don't want you to solve it, okay? Don't solve it. Just substitute the currents in the equation and get two nice equations in terms of V1, V2, V3. Now what you need to do here? What you need to do here? You can't keep it like that. You need to substitute that one from this. Make sense? So you need to put this IC here. Just substitute this part from this. Make sense? I will give you a few minutes. I hope you are okay with getting the currents. Just substitute this current in these KCL equations. That's all. And you don't need to solve it. I don't want you to find I1 and I2, but I want you to substitute this in the equations and simplify. Just get a nice equation. I'll give you a few minutes. I'm also going to do that, but you work on yourself, okay? So I'm going to delete this part and I'm going to substitute for the KCL equation, the first one. I1 we can write as 20 minus V1 over 2. I2 is V1. You don't have to look at what I'm doing. You can work by yourself if you are okay. So IC is V1 minus V2 over 5. You can't keep like this. We need to simplify. We are not going to solve it, but we make it to a nice equation. So what we are going to do is we get rid of denominator. So we times by 20. All the terms times by 20. So when you times by 20, this will be 10 because 2 times 10 is 20. So 20 minus V1 is equals to 20, 20 cancelling out V1 plus this is 24 times 5. So 4 times V1 minus V2. Now we get rid of the brackets. So 10 times 20 is 200. 200 minus 10V1 is equals to V1 plus 4V1 minus V2. We can take everything to the other side, V terms, so we can keep the 200 here and V1 plus 4V1 minus V2 plus 10V1. V1 I have taken to the other side. So the minus 10V1 will become plus 10V1. So now you can add the like terms. So V1 plus 4V1 plus 10V1 altogether 15V1 minus V2 is equals to 200. So this is the simplified version of the KCL equation to node 1. Any question? So if you get this, that should be enough for the first one. So you have another node. You had another equation which I deleted. You have to do the same to that one. So I will give you a few minutes for you to do that.
Something, I did something wrong in that first section. I was just trying to work it out.
What did you do wrong?
V2 I got was V2 equals.
Yes, four. That mistake is mine. So you have to times this one, which I haven't done. Yes, sorry. Yes, so 4V2. How about others? I'm going to do the other one. I'm going to delete this part and I'm going to do the other part. I hope you guys are okay with this one. So I'm going to write the KCL to node 2 now. KCL to node 2. We already wrote it. So IC is coming in, I3 is coming in, and I4 is going out. So we are going to substitute now. IC, I told you we can't, IC is fine. So it is V1 minus V2 over 5 plus I3. When you're writing I3, you have to put this, substitute this IC. So IC is V1 minus V2 over 5. 8 times IC minus V2 over 2. So this whole thing you need to write for I3. Makes sense? Is it okay? Is equals to I4 is V2 over 10. So this is what I got for the node 2. Did you get the same?
Yep, I got that.
Okay, that's good. Let's first simplify this part because it is a bit huge. So we are going to simplify that part. So we can say 8. We'll get rid of 5. So we can get rid of 5 by times multiply and divide 5 by 5 this V2. So 8 times V1 minus V2 over 5 minus 5V2 over 5 divided by 2. Now we have both 5 here. So that 5 we can times by 2. That will be 10 and we can write 8 times V1 minus V2 minus 5V2. Did I do anything wrong? Now we can say 8V1 minus 8V2 minus 5V2 divided by 10. So these like terms we can add these negative 8 and 5. Negative 13V2, 8V1, 10. So this will be your that part. I'm going to write it there. So we delete this part. Instead of this one, we can write this simplified version. So I'm going to write that simplified version. So we have 8V1 minus 13V2 over 10. Any question up to here? Now we can get rid of all the denominators. If you times all these ones by 10, you can get rid of denominator. Am I right? So you have 2 times V1 minus V2 plus 8V1 minus 13E2. V2 is equals to V2. So we simplify 2V1 minus 2V2 plus 8V1 minus 13V2 is equals to V2. Take the like terms, add all the V1s together. So V1, 10V1 minus, we have 2, 13, and this one also when it comes to the other side, it will become negative. So 13, 14, 15, 16. 16 V2 is equals to 0. You can further simplify. You can divide everything by 2. So you can simplify it further and you can say 5V1 minus 8v2 is equals to 0. So we have simplified this one. So you again have a equation with v1 and v2. Are we good? Did I do any mistakes in this one, or did you get the same?
I got the same as that. I just didn't
Okay.
simplify it.
Okay, yeah. So, how about others? Vivian, Matt, Lachlan, Dane, Brena. Are you okay? Okay, this is all you have to learn actually. If you understood this, all the questions are similar. Can I move on, or do you need more time? We have simple questions in the tutorial. Okay, so here we are covering the theory, but you can practice simple questions, starting from very easy questions and going to this one, harder questions with dependent source at the end of the tutorial. Okay,
This is the harder end of the scale, is it?
This is a bit hard, yes. The ones that at very beginning in your tutorial, you have the simple versions, like, without dependent sources. This one, or else the most simple one we did, this one. So the one that we did is, yes, it's not the very simplest one. So it's a bit hard, yes. If you can do this, that means because we have a dependent source here. But you guys are okay, you did this, so which is good. Okay, so let's do this one as well. Okay, so we are almost done. So the theory part, actually, not the questions. We'll do the question. Sorry. I want you to try this one as well. This is again a hard question. Okay, so I don't want you to do this exactly perfectly right, but I want you to try this, please. If you can do this, I'm confident that you guys are fine with the concepts. So we have again 3 nodes with 3 or more branches connected. 1, 2, 3. This whole thing is one node, and this is our reference, or the earth, which is voltage is 0. So we can assign a V1 voltage and V2 voltage. Then we have to assign currents. Currents are given to us. So directions are I1, I2, I3. This is I2, simple I2, and we have a dependent source 6I2. That's the given things, and I want you to this branch is already known, 1.5 amps. 1.5 amp is known, so you don't have to assign a current. It's already known current. Up to here, I hope you are okay. Now apply the KCL to node 1 and KCL to node 2. This is the last question. And then we have another theory part to cover. I'll give you a few minutes. Okay, so I'm also going to write the equations, but you can do by yourself. Okay, so currents coming into the node 1, so 1.5 amps. That's the only current coming in. So 1.5 is equals to currents going out I1 plus I2 plus 6 times simple I2. Now when I look at the node 2, you can write 6 simple I2 is coming in, and then another I2 is coming in, capital I2 is coming in, and only I3 is going out. Are we okay with this? Do you all get the same two equations?
Yeah, I got that.
Okay, now let's write the currents. If I write the capital I1 starting from V1 and going to 0 divided by the resistance, which is 4. And when I write the I2 starting from V1 going to V2, V1 minus V2 divided by 2. I3 is starting from V2 going to 0 divided by 20 volts, 20 ohms. And if you write 6, or else you can write, you don't have to write both of these ones. I1 is enough. So I2, simple I2 is here and here. So you can take 1. So if you consider this I2, you can write it starting from 0, minusing minus 80, minus V2 divided by 5, which is 80 minus V2 divided by 5. So I'm always writing everything here because otherwise you may go wrong when the things are different. So in case if you have plus here and minus here, then what will happen?
It'll be a negative.
Yes, so this one will become a positive and this will become a negative. So you have to always follow from the beginning. Just don't avoid steps. We can go wrong easily. So we have to carefully do this one. Okay, now 80 minus V2 over 5. Okay, so we have everything. Now we can substitute. So when I substitute this 1.5, I1 is V1 over 4, I2 is V1 minus V2 over 2, plus 6 times 80 minus V2 over 5. So that's the equation. You can get rid of the denominators. You can times everything by 20 maybe, because you need to get rid of all these denominators. 4, 2, so common. You can times by 20 all the terms and you can get rid of that. I hope you're okay with that. So 6 times I2, you can write 80 minus V2 over 5 plus I2 we found 80 minus V2 over, or else you can add these two together. See, these two you can add and you can say 7. Plus I2, capital I2 is V1 minus V2 over 2 is equals to I3 is V2 over 20. Are we good? So now getting rid of the denominator, you can times all the terms here by 20 and you can get rid of the denominators and you can simplify. Is that clear? Any questions? So these are the harder questions. Okay, so you will get something like this in exams, not the very simpler ones, but the simple ones you have in the tutorial, a lot of simple ones, so you can go step by step. when we do on Wednesday, I will start with the very simple questions and we are going to these ones. But this, if you understood this, you should be able to do all the questions in the tutorial. Any question? There is a one small theory part. We'll cover that one as well. Then we are done. Before moving to that, do you have any questions up to here? Okay, I assume you all are okay. Okay, now there is a special case called supernode. Supernode exists when you have a voltage source alone between two nodes. So you can see here, from this to this, you only have a voltage source alone, no resistor. So when you have a voltage source alone in between two nodes, we call it a supernode. So supernode questions are solved in a different way. So when I'm not going to show you how to solve this one, but I want to tell you, I'm solving this on Wednesday because I want you to try the other questions, simple questions before coming to this one. But if you find any question in your tutorial with a supernode, just keep it for us to do on Wednesday together. Otherwise, all the questions you can do. I will show you the difference here. When you have a supernode, you consider this as a single node and you consider KCL to the supernode. You apply KCL to the supernode. So what are the currents coming into the supernode? This is coming in, this is going out, this is going out, this is coming in. So you write it as I1 plus I4 is equals to I2 plus I3. So this is how you write the KCL to supernode. You just consider it as a single node. Now, the other part is when you are writing the I1 is starting, same thing. I1 is starting from this node, V1, and it is going to V2 divided by 2. When you write the I4 is going this way here. Starting with V1, going to V3 now. See, this side is V3 divided by 4. I2 is this V2 minus 0 divided by 8. I3 is starting from V3 minus 0 divided by 6. That's the only difference. Don't do this kind of questions, but we are going to do this together only when you have a supernode. You need to consider it as a single node. How do we identify a supernode? When you have a voltage source alone across two nodes, that we call the supernode. So solving supernodes is very easy, same as the previous ones. Only thing is you are applying the KCL to the supernode. Make sense?
Yep.
Okay. So this question I'm not going to solve because I will solve it after we do the tutorial questions. We have these kind of questions in the tutorial. We'll come back to this question and we'll do again after we do more questions, simple questions. That's the whole theory we have for this week. We can discuss if you guys have any question. We have time.
I feel like I'll need to do repeat that process a few times to have it.
Yes. That's why I don't want to do this supernode as well. You can practice it with the tutorial questions because it is starting with very simple questions.
Yeah.
And I will put this in views, this one today. So you have, I told you every week you have one page summary for everything. So you have this summary up this part we haven't done. We are going to do it on Wednesday, but this left-hand side gives you all the summary that we have done. And I will put this in views for you to have a look. The whole PowerPoint. Okay. Yeah, so that's all from me. If you guys have any question, we can discuss. Otherwise, I'll see you on Wednesday.
Thank you, Miss.
Okay. Okay, so I will see you on Wednesday. Looks like you don't have any questions.
I'm good, thanks.
Okay. Oh, so I'm winding up the class, guys.
Thank you. Have a good one.
Thanks, you too.